Okay, so I will start my today another live coding session. So today I will solve this question, clone graph. So in this question, I'm giving a reference of a node in a connected undirected graph. Connected undirected graph. Okay. Return a deep copy of the graph. Each node in the graph contains a value int and a rest node. Each node in the graph contains value int and rest node of its neighbors. Okay. Test case format. For simplicity, each node's value is the same as the node's index unindexed. For example, the first node with var is equal to 1, the second node with var 2, and so on. The graph is represented in the test case using an adjacent list. So this is the test case format. So yeah, I actually don't have to take care of this that much. And an adjacency rate is a correction when another list. Sorry, an adjacency list is a correction of another list used to represent a finite graph. Each list describes the set of neighbors of a node in the graph. The given node will always be the first node with a var 1. You must return the copy of the given node as a reference to the cloned graph. Return the copy of the given node as a reference to the clone. Okay, so I have to, initiate the brand new node, which corresponds to each node in the given graph. Good. Okay, so firstly, I will try to understand this question. So the input of this question, or just say the method, is the node, which is one of the graph, one node in the graph. And one edge case I'm thinking is, it is possible that the graph is completely empty or not. I will check the number of nodes in the graph is in the range 0 to 100. Yes. So as the edge case, I can say so if the given node is none, then I should just return none. So this is what I will take care when implementing the code. But anyway, what I will return in the method is node. Yeah. So this should be the node number 1. It doesn't matter, but it says the first node with var 1. So this should be the node that will be given, and I will return this. But this should be the brand new node object, obviously. Okay, good. So aside from this, I don't come up with other edge cases. Yep. Oh, by the way, I don't know if this matters that much or not, but I just want to confirm if there are duplicated connections, edges between two nodes, or I should say parallel edges, which connects the same two nodes. And I can see no repeated edges. So this, no. And also, I can see self loop. It doesn't exist. Yes. Okay. And because the given graph is connected, I can always visit any node from the given node. Good. Okay, I will think of some examples. So let's say the node is connected like this. So what I need to do is firstly, I copy the node 1 and then, let me change a little bit. Let's do this. I will take a look which node is connected, and if this, node 2 is connected, I will create node 2. If node 3 is connected, I will copy node 3 and make it like this. Yeah. So once I create this, I can say the copy of node 1 is completely done. I don't have to see this anymore. So I will try to see this node, or I should say this node. Let's say I have one more node like this. Oh, this is undirected. Okay, so in this case, I still don't have a reference to node 1, node 4. So I still can't start node 4 next. What I can access, or I should say, well, the nodes I have the reference is node 2 or node 3 now. So let's say I will start from node 2. Then if I start from node 2, I will copy this edge. This edge is already copied, so I don't have to do this. But 2 to 3 is not copied yet. So I create this edge. Then now the node 2 copy is completely done. So I will try node 3 copying. And actually node 3 is already created. So what I have to do is just doing the edges copy. And when I try to do the edge copies, I find node 4. So I copy the node 4 and connect the edge, connect with the edge. Then node 3 is done, and I will take away node 4. And I find that node 4 is connected to node 3. So edge copying is already done, node copying is done, so node 4 is done. And now I can say there's no any more node. So good. Okay, so I think this is a possible approach. So what I did actually was BFS on the first node. And on each node, what I would do is copy the edge, or I should say, I would take a look for each edge. Then copy the edge, copy the connected node if not existing yet. Also, I will copy the edge if not copied yet. Not copied yet means that, say, if I'm at the node 2 and I find the node, edge 2 to 1, this 2 to 1 is already drawn when 1 to 2, in this case, it's already drawn because 1 to 2 is already found when I was at node 1. Yep. So I think this is a possible approach. And when I think of this, my concern is how do I check if node is already exists or not? And same for this edge. So node.var is unique for each node. Yeah, this makes everything so easy. So I will keep track of index to var to old node, new node mapping. So with this, in line 32, when I copy the connected node, say I try to copy 2 to 3, I can reference, the value 3, and if old node, okay, so what I would do is, if I find a new node, I always create the copy node immediately and register it into this hash map. So in that way, when I'm at node 2 and when I find the edge to node 3, by referencing the var 3, I can find the copied node. So I can connect the edges. So what I can do, and also one more thing. In line 33, if I try to see node 1 to node 2 is already, oh wait, actually in line 33, I have to copy the edge because what each node has is a neighbor node. So even if I put the reference from node 1 to node 2 in node 1, I have to put the node 2 to node 1 reference. Oh, okay. So I will definitely copy the edge. I will do this always because I visit each node and each edge only once when doing the BFS. Okay, good. So with that being said, the time complexity should be, assuming the V nodes and E edges in the given graph. As I said in the BFS, I visit each node and each edge only once, so it should be V plus E. And for space complexity, I need this value to node mapping. So it should take OV. Yep, so that's the complexity analysis. Okay, so I will start the implementation. So what I will do is first recreate the hash map. So and if node is none, I return none. This is the edge case. Otherwise, and I will create the node copy of the node first. Copy of the given node. Yep. And neighbors is the rest. Is not known else. I will just make it explicit. So I copied the first node, which is node 1, and I registered it into the hash map. And also I have to keep the reference into this copied node because this is what I will return in the end. Okay. So here I will do the BFS. So I don't want to visit the same node again, so I will do this. So, oh, by the way, when I copy this node, I also had to, copy the neighbors also. But let's do that when I pop up the node from the queue. So here, I will copy prev to something edges. Yep. And in that process, also I will do is if X node I will register this if needed. Yep. And also what I will do is, and also I have to, push unvisited X's into the queue because I have to visit those nodes. So basically, this is what I will do in this method. And also other two visited set. Okay. So this is how we get the current node, next node. So firstly, I will register this node if it's not existing yet. Yep. Then okay. So I registered it. So now what I can do is this is optional, as I said, if the neighboring node doesn't exist yet. And now it exists. So what I would do is makes a copy. I mean, so I register it, then copy node is this. Okay. Oh, by the way, I think Bart knows. I think I can just do it to original to, copy node mapping. Yeah. So let's just say mapping. This is clear enough. Let me just rename it to just copy. Okay. So here, if current node is not in the mapping, I copy it and then register it into the mapping. Good. Okay. And that being said, now I get the copy node. So what I'll do is current to copy node edge should be copied. Current previous neighbors. Copy, yes. Previous. Wait a minute. Also, I need previous copy and current copy. So current copy. Yep. This should be mapping. So here the prev copy. Okay, so what I'll do is prev copy to current copy edge should be copied. Yep. Wait. Do I have to keep the order of the neighbors list? Probably yes. And it sustained because I'm iterating prev to neighbors. And in that order, I am appending current copy to prev copy. So, yeah, order is sustained. Good. So now I've done copying the edge. Oh. Okay, so I've copied it. So the last thing I would do is pre-push if current node is not visited yet. Oh, wait a minute. So here, I had to do if current is already in visited, I just keep because I don't have to visit it anymore. What do you mean? It's so heavy. Okay, so if current node is already visited, I just have to skip. Yep. Otherwise, I will mark this current as visited. Yep. So in this way, I don't have to copy I can avoid copying copying the edges from the same node multiple times. Good. So now current should be added to visited. Let me do something at the end. Here, current is added to the visited set, and also current should be appended to the queue. Good. And in the end, I will return the copy node here. Okay. So, yeah, I think this is it. Let me double check. So, okay, so firstly, I copy the first node and create the mapping of node to copy. Yep. Then I push the first node into the queue. I have to take care that nodes in the queue, I can say node itself is copied, but edges from the nodes in the queue are not copied yet. So when I pop out from the queue, I have to copy edges. And I also created visited set. This works as the blocker when I push node into the queue. Yep. Oh wait. So visited, current is in visited, I continue. Am I correct? Current, no. Current is in visited. I avoid putting into the visited set later. No, putting it into the queue in the end. So I can say, if current is not in visited, I do this in the end. Wait a minute, current is already visited. Even if this is visited already, obviously I have to copy the edge. I have to do that, but I don't have to visit it again. So if current is in visited, I don't have to append it in the queue. So yeah. Okay. So I will come back. And so if there is an element in the queue, I pop it out and create the mapping prev copy. So, and it is guaranteed that the previous node mapping is already created. Always guaranteed. I can do that. And for current node, for each neighboring node from the previous node, if it's not copied yet, I copy it. Yep. And also, if of them copies the edge, then for the current copy node, if not visited yet, I push into the queue so that I can copy the edges right. Good. Okay. So my code, but so let me dry run my code. So firstly, for edge case, if I'm given node none, yep, in line 48, I return none. That's okay. And I will check one more case. So, wait a minute. Okay, so I told you that the edge case works. So now I will think of the very simple case. So let's say this one. Yep. So in this case, firstly in line 51, I copy the node and return is pointing to the copied node. Good. And this is actually the copied node. And mapping node, mapping has now node copy 1 to the copied node. So let's say this should be node 1, this should be 2, and this should be pointing each other with node 2, 1. So I first recopy the node with empty neighbors. Then this is the copy, yes? And mapping has node to copy. So let's say this is number 1 and number 2. Let's say this is C1 node. In this case, 1 is pointing to C1. Good. So, and in Q, it has only one node, which is asterisk 1 node. Yep. And visited set, it should have only sharp 1 now. Good. So in line 67, there's an element in Q. So I pop this out. And now previous sharp 1 node. Yep. And so prev copy is mapping prev. So this should be sharp1 to sharp c1. The prev copy is now sharp c1 node. And in line 70, prev is sharp1, sorry, asterisk 1. Asterisk 1 node dot neighbor is only node 2. The current is now node 2. Okay. Then in line 72, current is not in mapping yet. So in line 73, I copy the current copy, which should be 2 empty, and let's call it just sharp C2 for the reference. So now current copy is sharp C2. So mapping current asterisk 2 is pointing to asterisk C2. So this mapping is now created. Good. Okay, and now I go to line 81. No. And I have to copy the edge. So now in line 76, current copy is mapping of the current. Current is asterisk 2. So now it is asterisk copy 2. Good. Then prev copy dot append current copy. So prev dot copy. Oh, this is not correct. Neighbors. Yeah. Dot append current copy. So now prev copy is C1. So C1 dot neighbors here should be appended current copy with this C2. Good. This is as expected. Yes. Okay. And now current, which is asterisk 2, is not in visited. Yeah, not in visited. So I added to the visited list, and also I appended to the queue. So now sharp2 should be appended. Okay. I basically covered all the line already, and so far everything looks good. So I will speed up. So now prev is sharp2. Yep. Then in line 69, prev copy is obviously sharp C2. Yeah. Then in line 70, prev.neighbors as current, yes, because prev.copy is this one. Sorry, wait me. Prev.neighbors. Current is prev.neighbors. Yeah. So current, which is asterisk 2, is in the mapping key. Good. So I go to line 76 and get the current copy, which is now asterisk C2. Sorry, no. Wait. So current is now asterisk 2. No, asterisk 2. Sorry, current is the neighbor loop, previous neighbors. It should be now asterisk 1. So current copy mapping. So asterisk 1's mapping is asterisk 2, asterisk C2, no, asterisk C1. So asterisk C1 is the current copy. Yep. So maybe I just renamed this to neighbor instead of the current. Yeah. But anyway, so now I can say current is not in mapping. This is not true. So I go to line 76, and the current copy is this one. Neighbor. This is the neighbor copy of the neighbor. So prev copy the neighbors append current copy. The prev copy is here, the current node, actually, the C2, and I will append C1 to this. So it looks like this. Yeah, good. And current is already visited because asterisk 2 is already in the visited set. I don't do anything, and go out of the for loop. And now length of the queue is now 0 because I've already popped this out. Yep. So I now will return the read, which is copied node 1. Good. Okay, now I've covered all the lines, and I'm pretty confident in my code because I've just dry run. So I submit it. Oh. Good. It's a code practice.